What's up, everyone? It's Emil again. Today I'm going to go over doing an effective mass calculation using VASPKIT. So there's not a lot of good documentation on the VASPKIT website. However, I did find sort of an unofficial Chinese website that pretty much walks you through these steps. So it's actually pretty simple. So you start off by doing VASPKIT, and then let's say, for example, actually, before I even do this, my assumptions here are you run the regular relaxation, then you do your band structure, your self-consistent field, and then you analyze the band structure. Okay, well, how do you get the effective mass calculation? After that, you sort of want to analyze, your band structure K-points file. So, I know what the points are. I looked at, the place of interest. But also, VASPKIT option 911 determines automatically sort of the valence band minimum and the conduction band maximum, which will be of interest in hopefully your semiconductor. So I'm using obviously a metallic system. So this isn't, it's not made for this, but this is, how do I say this? This is particularly the easiest option if you're dealing with something like this. Otherwise, you'll have sort of errors thrown at you. And if you look at Sumo, Sumo is another great option to use. It's all in terminal, so you could do Sumo band stats once you already have your band structure, and it does the calculation automatically. But this is granted, if you have a metallic system, it will not continue with these. So in this situation, VASPKIT is preferable, and you don't have to interact with anything else. So I already know the high symmetry points that were of interest for me. So when you originally set this up, your input.in file will be 1. That will generate your K-points file. Okay, and then if you look at the K-points, it looks like this. And, to do that, right, you prepare the input file, and then once you use VASPKIT 911 for the band edge analysis, then you could run through with the input file that I just looked at. And then for that, you do VASPKIT option 913. Option 913, once you write in everything of interest from your input file that looks like this, right? I want to find it from A to Z, A to R, A to M. And this is the A, this is the Z, this is the A, this is the R, this is the A again, and this is the M K point. And that comes in from your band structure K points that were right here. So it reads the energy levels from the eigenvalue file, input parameters from the in-car, and it also reads the input file, and it'll give you the effective masses of electrons and holes, respectively, along particular high symmetry paths. And again, it's pretty simple. The only caveat is that you're going to be using the input file twice, right? So you set it to 1, and then it gets you the K points. Then you set it to 2, and then you actually run it. And all this is written down on my tutorial page, so you could copy and paste as needed. So it's very simple. If you guys have any questions, please feel free to reach out or comment down below, and we'll get to it. Thank you again, and see you soon.